Hi, Assalamualaikum. So we proceed to the last chapter for this semester, which is thermodynamics. So thermo here meaning that thermal, which is also equivalent to heat, and dynamics meaning that work. So in this chapter, we are going to learn about the energy transfer in terms of heat and in terms of work. Okay, before this, we have learned in chapter 5 that energy can be transferred if we are exerting a force on the object. Okay, energy can be transferred as a result of force. This one in chapter 5. And we also learned in the previous chapter, chapter 13, that energy can also be transferred when there is a temperature difference. So in this chapter, okay, we are going to see the energy transfer on the system due to heat and due to work. Okay, so in this chapter, there are 3 subtopics. I'm going to explain the first subtopic in this video. Okay, so untuk first subtopic here, we have 2 learning outcomes. First is you should be able to state the first law of thermodynamics. Second one, solve problems related to first law of thermodynamics. Okay, kita terus tengok kepada first law of thermodynamics. Okay, the first law of thermodynamics states that the change in internal energy of a closed system, which is delta U, will be equal to the energy added by the system by heat minus the work done by the system on the surroundings. Ataupun kita boleh keluarkan equation of first law of thermodynamics, delta U, which is change in internal energy, equal to heat minus work done. Okay, now it's important for you to remember the sign convention whenever we are doing the problem solvings in this chapter. So here are the keywords that you can use to identify whether the sign is positive or negative. Okay, so imagine we have a closed system. Closed system meaning that the mass remains constant, but the energy can increase or decrease. So energy increase and decrease usually whenever we see there's a change in pressure, volume, and also temperature. Okay, so when we have heat added into the system or heat is observed to the system, meaning that okay, the value for Q will be positive. If heat is out of the system ataupun release out of the system, Q will be negative. Okay, if work is done on the system, okay, the keyword here, work done on the system, ataupun usually kita akan gunakan keyword compression. Okay, kalau ada keyword compression maksudnya work is done on the system, so work will be negative. And if work is done by the system, or we can use the keyword expansion, when there is expansion occurs in the system, meaning that work will be positive. Okay, usually by logic we can say that whenever work is done on the system, okay, it will gain heat. Okay, dia akan gain heat. Maksudnya kita lakukan kerja kepada sistem. So sistem tu dia akan observe heat. Apabila work is done by the system will release heat. So usually this is what happen in the system lah. Okay, so just make sure you get the keywords right here so that we can identify whether the sign is positive or negative. Okay, now let's look at the first example. 2,500 joule of heat is added to a system and 1,800 joule of work is done on the system. What is the change in internal energy of the system? Okay, so here we have the keywords. Heat is added to a system and work is done on the system. So when heat is added, Q will be positive. So positive 2500 joule. And work is done on the system. So kalau on the system, here on the system, work will be negative. Negative 1800 joule. So now what we want here is the change in internal energy. So delta U will be equal to Q minus W. So masukkan, mesti masuk sekali dengan sign convention. Delta U will be equal to 4300 joule. Okay, next one. A gas expands under constant temperature condition and does work of 30 joule against the surrounding. First, what is the change in internal energy of the gas? Next one, find the amount of heat observed or lost by the gas. Okay, so here we have the keywords. A gas expands under constant temperature. Okay, so if there's a keyword expand ataupun expansion, this one here, expansion meaning that the work is done by the system. So W will be positive. So here W will be positive 30 joule. And then under constant temperature. So constant temperature here meaning that delta U will be equal to 0. There is maksudnya kalau sistem tu tiada perubahan temperature, actually nama proses dia dekat sini. Kita akan belajar dekat 14.2. Nama proses dia adalah isothermal. So apabila di dalam isothermal process, there is no change in the internal energy. So delta U will be equal to 0. So untuk B, we want to find the amount of heat observed or lost by the gas. We want to find the value for Q. So delta U is equal to Q minus W. Since delta U will be equal to 0, Q will be equal to work, which is also equal to 30 joule.